Welcome back to my channel. In this video, I will be discussing about the various evolutionary models. In my previous videos, I have given an overview about the significance of process models and the prescriptive process models such as waterfall model, V model and incremental model with RAD as an example. In this video, I will be explaining about the evolutionary process models. These evolutionary models are evolving with time. So these models are highly iterative in nature. Different examples and types under evolutionary process models are prototyping model, the spiral model, and the concurrent development model. The evolutionary process models are said to deal constantly with the changing requirements. So, whenever the requirements are not clearly understood or they are very fuzzy, in that case, we can go to develop a particular software using this evolutionary process model. These models also provide an initial version of the system very quickly. It also involves all the development teams to work across various phases of the process. However, whenever there are bugs, then the quick fixes to those bugs might be provided. Also, invisible process does not support documentation to the fullest. The system structure can also be corrupted by continuous stages. So, in evolutionary model, special tools and techniques might be necessary. The client also may have the impression that first version is very close to the final product and thus they will be less patient, where the first version is the prototype. Applicability. Whenever the requirements are not well understood, then evolutionary process model might be preferred. When the client and developer agree on the rapid delivery of a prototype that will be either considered or may be thrown away at later phases, then the evolutionary process model might be preferable. It is also used only for small and medium sized software systems, but it is inefficient for larger process works. Evolutionary process models are said to be iterative. So, we need to understand what is an iterative model. So, with iterative development, the software changes on each iteration, it evolves and also grows with every iteration. Also, as each iteration builds over the previous one, the software design is said to remain consistent. That means there is no change in the design. As software is delivered in parts, there is no need for a full specification from the project start, and small changes to requirements are possible during the course of development process. However, the requirements can't change radically. Major ones must be defined in the beginning, especially those for the system design and for large mission critical enterprise applications such as microservices or web services, these iterative models are applied. Hence, there is no much change during the planning, requirements analysis and design phase, but when we are progressing with the other phases, there might be major changes which are encountered. One of the famous iterative or evolutionary process model is the prototyping model. In this prototyping model, we focus on the prototyping concepts and requirements will not be clearly understood. We come out with an initial version of the prototype, working prototype, which may or may not be considered for the final development of the overall product. Also, it relies on the development guidelines. So this prototype, it serves as a first system. It is basically an information gathering technique which is useful in seeking user reactions, suggestions, innovations and revision plans. This prototyping is used as an alternative to the overall system development life cycle. Users will get a feel for the actual system and developers will get a chance to build something immediately, used when requirements are fuzzy. Also, a customer defines a set of general objectives but does not identify detailed input, processing, or output requirements. So reactions are initially gathered from the users, which are of three types. Either they may be based on the user suggestions, they may be based on innovations, or the revision plans received as a matter of the iterative approach. So this is how the prototyping briefly looks like. So when the SDLC model is having certain problems, then this prototyping can be used as an alternative to SDLC model. So the two main problems associated with SDLC, where SDLC stands for Software Development Life Cycle, which carries out various phases right from requirements gathering to analysis to design, modeling, construction and deployment. The problems that are occurring during SDLC phases are extended time might be required to go through the development life cycle. User requirements may change over time. Prototyping may be used as an alternative. So the guidelines to develop prototype are: it is necessary to work in manageable modules. It is necessary to build the prototype instantly or quickly. It is also required to modify the prototype in successive iterations. This will create a stress on the development of the user interface. The major advantages of this prototyping approach are: it is potential for changing the system early in its development. It provides an opportunity to stop development on an unworkable system. Also, there is a possibility of developing a system that closely addresses users' needs and expectations. However, it also is associated with certain limitations where managing the prototyping process is difficult because it has to be developed rapidly and iteratively. Requires feedback on the prototype, and once the feedback is provided, once again the refinement has to be carried out. Incomplete prototypes may be regarded as complete systems sometimes due to exceeding the time limits. The prototype also will be evaluated by the system analyst. So this system analyst will work systematically to evaluate the user's reactions to the prototypes. They allow the user, okay, to involve in experimenting with the prototype, in giving open reactions to the prototype, and also in providing suggestions to add or delete from the prototype. The next category of evolutionary process model is the spiral model. This spiral model is proposed by Boyle. It provides the potential for rapid development of incremental versions of the software. A spiral model is something which is divided into number of activities, also called as task regions. Each of the region is populated by a set of work tasks called as task set. This is how the spiral model looks like, where we have various phases arranged across this particular model, starting from planning, customer communication, planning, risk analysis, customer construction and release, and the customer evaluation. So the main characteristics of spiral model is it deals with risk handling capabilities. Also, it is a hybrid model that supports the process development iteratively. Here, in this model, the process is represented as a spiral, where each loop in the spiral represents a process phase. There are four sectors as shown in the figure per loop. So, these four sectors represent objective setting, risk assessment and reduction, development and validation, and planning. In this model, risk is explicitly taken into consideration. Hence, to reap the benefits of the model to the fullest, we need to engage people with a strong background and expertise in risk evaluation. A typical spiral iteration lasts around 6 months and starts with four important activities. They are thorough planning, risk analysis, prototype creation, and evaluation of the previously delivered part. Repeated spiral cycles seriously extend the project time frames. This is the model where intensive customer involvement appears. They can also be involved in the exploration and review stages of each cycle. So, however, at the development stage, the customer's amendments are not acceptable. So the major advantages of spiral model are: it helps to deal with the risk and reduce the risk mechanisms. It supports iterative and the reflective nature of the real world problem solving. It provides a systematic approach to deal with the problem. However, the disadvantages of the spiral model are it requires expertise in risk evaluation and reduction. It is complex and relatively difficult to follow strictly. It is applicable only to large systems. Hence, it is suitable only when the large systems have to be developed internally. Different use cases are available, particularly in the research and development activity or to introduce a new service or a product. This spiral model is said to be extensively used. There is a variant of the spiral model called as win-win spiral model. So, in this win-win model, to obtain the project requirements, customer communication plays a prominent role. And it suggests that the proper communication with customer enables to simplify the process of negotiation, which means that the compromise has to be faced by both developers and customers. Neither there is a win situation for customer nor for developers, but in fact, both the participating entities, that is customers and developers, they will agree and then only the negotiation will occur. So this will result in a win-win situation. That's all from my end for this video. In the next video, I will be explaining about the specialized process models, which is the last models under prescriptive process models category. Thank you for watching. Please like and subscribe my channel.